Whew. All right, I think I got it under control this time. We about to get started. Um, what's good? Names Tess. Here to teach you about stats and cues, at least a little bit. This probably be have to be broken up to like 3 or 4 parts, but I'm more confident before. I tried recording before, had a little mishap. We about to get we about to get it started. All right, so um, screen share, 3, 2, 1. All right, what's up, everybody? It's Tess. Welcome. This is going to be the first of many, many, many attempts of trying to digest what's going to be on the exam. Let's just jump straight into it, man. And ladies. So this is SB20, Prep 1, Stats and Cues. This is one of the supplemental forms out of 5. Let me explain what you guys are looking at. You guys are in spring 2020. This is our semester, taking it with Professor Brian Murphy. I have previous exams, which I gave to everybody. There's about 14 of them that I gave out. And within these 14 exams, there is, sorry, I'll take a sip of water. Within these 14 exams, there's questions. These questions will most likely be on the exam in some type of form or another. So this is our attempt at solving these questions. I'm sorry that I'm a little bit, all over the place right now. It's pretty early in the morning. I stayed up all night trying to get these things together for y'all because most likely when I wake up tomorrow, I'm going to be doing the same thing again and again and again and again until we get through this whole exam as best as we can. I have no problems doing this. I want to pass. I know you guys want to pass, so let's just do this. Let's jump straight into it. Here's the heresy: yellow, green, blue. Blue, let's start there, is Q. Anything related to Q, I highlighted in blue. Remember, this is in stats and Qs. These are all the exams right here on the left-hand side, numbered from 1 to 14. All the questions are in blue are questions that were asked. Like, for example, this was the summer 19 final A. This was related to a Q in some type of way, shape, form, or fashion. Sometimes it has stats. Just know that the blue is Qs, and I did it like that for a reason because they could be answered together. So I started at the blue. The green is the second level, so their implementation of stack integer code. So like implementing a stack and the code necessary for it, that's in green. Very short. We did it a lot in class. All the other stuff we went over, but it's hard to digest everything when the professor tells it, and I have a hard time with it. So this is the only way that I could really see what's going on is just piling up everything and putting them together. So the yellow one is the ones that we'll be doing today, which are the trace the integer infix evaluation algorithms. There's questions that along with it that relate to each other, so I just lumped them up to this big lump sum. Just imagine if I deleted all the yellow ones right now, all you would see is blue and green. And that's what we'll focus on part 2, part 3, part 4, whatever we got to do to finish up stats and cues. That's what we're going to do. Now, let's look at the yellow ones. On test 3, 4, 7, 8, 10, 12, and 13, there was a trace integer infix evaluation algorithm with the exception of 4, where it had a palindrome. If we're able to understand this trace, the evaluation algorithm, and try to understand the questions after it, will be just that much more stronger in doing this exam. So I lumped everything together. I said, let's look at it, let's see what we could do, and then let's move on from there, because I know how to do this and I'm fairly confident in teaching you guys this right here. So that's what we'll do now. And afterwards, we'll answer some questions, but let's just first start with doing the first part of most of these questions, and sometimes even the only part of the question. like with number 8, which I'm going to do now with you. So I'm going to share my screen. I have an iPad here, and I hope you guys see what's going on with my iPad. Just give me a second. I just moved it around a little bit. I want to make sure that you guys can see what's up. Yep, I seen the 3. So if we look at the question from, I'm going to say it to you guys so you guys can pick up your paperwork or grab the paperwork now. And oh, here's an awesome thing with YouTube too. When you're on YouTube, you could speed up the footage. So if you guys feel like it's ever too slow for you and you guys got to get to a spot, just speed up the footage and I sound like a chipmunk and you guys don't have to listen to me keep on talking and this and that. We could just get to where we need to. That's why I love videos, and hopefully this helps. Like, this is not supposed to be replacement for the teacher. This is supposed to just hopefully have you think about and solve problems, continue to solve problems, and break through those barriers that you may be facing like I am. So we're looking at exam number 8 from the fall 2018 final, B1. I'm doing this one specifically because it doesn't have a part A or part B. I just want to solve the straight problem. The problem says, trace the integer Infix evaluation algorithm for the following. It is 7 minus 3 times, parentheses, 3 times 4 minus 2 caret 3 plus 3 times 2 plus 1. So now, this is all related back to PEMDAS and what we learned in middle school when we learned PEMDAS. I'm just going to write it over here. We're going to solve this. We're going to solve this one by one. So we're going to take this, we're going to solve it first, and then after we solve it, we're going to go ahead and do the postfix. We're going to do the further parts of this question. So with PEMDAS, it could get very tricky. So like when we look at this and we go, okay, necessarily what is it that, you know, we could potentially mess up on? The parts that we could mess up on are, you know, not doing the operations correctly. So I'm going to show you how I do it. And this is not necessarily for you to say, okay, I'm going to do it exactly how Tesla does it. Now, this is just because I'm very thorough. So when I do something, I know that it may look funny, but I have to do it in that way. So we're up to the first P, which is parentheses. So I'm just going to tackle everything in the parentheses first. So now we're looking at multiplication here. And this is the exponent. So it's P, then E, then M. One more line. So that's the heresy right there. So I'm going to do this first. 2 raised to the 3rd power is 2 times 2, which is 4, times another 2, which is 8. Then I'm going to put the 3 times 4 over here, plus 3 times. I could do this now since it's in parentheses. I could go 2 plus 1 is 3. And I'm going to constantly leave that in parentheses because we're not done with it. So now I can move down to the next line, which is handling more of the multiplication inside of the parentheses. We're just handling the parentheses right now. Then we looked at the exponent. So let me just put another P. So our first point, we're going to go 12 minus 8 plus 3 times 3. We're going to keep leaving that in the parentheses. Once again, we're doing parentheses. That's all we're doing right now. If you just remember PEMDAS, you'll be fine. Just keep doing the parentheses and just working from there. So we'll do 12 minus 8 is 4, if I'm not mistaken. I'll do it again in my mind. 8, 9, 10, 11, 12, and my fingers. And we have our parentheses, keep on coming down. And then this is the last time for the parentheses. So now what we'll do is we'll look at multiplication right here. So that's going to be our new heresy, multiplication. And then everything else is PEM dash. So division, no division here. What we'll have is subtraction, which is second. Or I should say PEM dash. So subtraction would be last, but we'll have addition. Addition right here. Sorry if I'm going too slow, yeah. And just give me a second. And then we'll have subtraction here. So figure this out, subtraction here. Had to look away from the screen for a second. Now, what we'll do is we'll go down a little bit further. You'll see that multiplication has to be done here, which is a 9. I see that multiplication is here. It's a -3 times 4, if you see that. You could put a 12 there if you just see the 3 times 4, and then put a negative in front, and then bring down your 7. Now, what we'll have to do now is the actual subtraction, well, addition first, so that's our new heresy, and then subtraction. So that's what I'll do. I'll do -12 plus 9, or I could say that is, -12 plus 9. You have to be careful, especially on this level. So this would be 9, 10, 11, 12, which is a -3. All right. And because I look at it like the 9 goes into the -12. And then from here, it's 7 minus 3, which gives us our answer of 4. Now, we did the actual trace. That was the actual trace. That was it right there. So I'll leave this on the screen. Maybe you guys want to take a quick snapshot of that. But I'm going to switch over to the screens now, and I'm going to pull up a calculator. Just start a new share. So back at my screen, I'm going to pull up the calculator, and we're just going to do this out really fast. It was 7 minus, we could look along right here. It was 7 minus 3 times a bracket 3 times 4 minus 2. We're going to have a caret 3. Going to close the bracket, plus 3 times bracket 2 plus 1, close the bracket, and this is our answer. If I press enter, I believe it's just going to just display right there, but our answer is equal to 4. So we know we did our addition right, we did our calculations right, we did our PEMDAS right. We could move on to the next part of the problem. The next part of the problem is going to be the actual calculation of the Postfix. So with doing Postfix, it's a bit tricky. It's tricky because if you don't understand it, you could make a mistake simply somewhere and it'll mess up everything. We have to be very precise with what we're doing. So let's look at something like, we're going to use the same question, of course, but is one of these questions like number 3, trace the integer infix evaluation algorithm? Be sure to indicate the evaluation postfix expression. So something like that. It also is in number 7, that last part. And let me see if there's any more. Yeah, and number 13. So 3, 7, 13 have that extension on the end of it. And that's probably what he's going to ask at the on our exam if he gives this question, and most likely he will. Definitely on the test he'll give this and say, calculate the postfix expression. So if you know how to do this, that's an easy 10 points for stats and integers. So let's move on to that. So I'm going to jump back over to the whiteboard on my iPad. We're already about, I keep track of the time, we're at 15 minutes. So this may take another 5 to 10 minutes. And then we have some more questions. So this may take 30 minutes in total. I as well have to go to the supermarket and grab some food. So let's go ahead and just do our question here. So I'm going to rewrite the question. I'm going to do it in black once again. So we're saying 7 minus 3 times bracket 7 minus 3 times 4 minus 2 caret 3 bracket plus 3 multiplied by 2 plus 1. Boom, that's it right there. So now let's do it. You guys ready? Ladies and gentlemen, here we go. So we're going to create a stack. It's going to be known as the stack. I wish that I had made it a little bit bigger, but it's all good. I'm going to just zoom in just a bit. I hope my screen is sharing. I'm hoping you guys are just watching along with me. Yep, double chat. And this is our stack. So what happens? The operators, so this is going to be like an OP stack. OP stack. I'm going to put it down here too. Then the numbers, the actual, how is it? The operands. The operands are going to go out here. So the numbers. So we'll just go like that. Because the operands are going to go out there, the operators are going to go in the stack, but then we're going to pop them out. So let's start with 7. I'm going to do it in blue so we identify where we're at. So we're starting there. I'm going to go 7. Gets popped into the, it's going to get popped into the actual, the field. I'm going to call it a field. Let's call it field. Fi. Let's call it field. I don't know. Now we're looking at the next place, which is an operator that gets pushed into the operator stack. It's an operator. So now we look at the next one. We just go by place, which is an operand, and that gets pushed into the field. Then we look at the next one, which is an operator. Now, before I put this multiplication in, the heresy is the same as PEMDAS. So if it's multiplication, it stays on the top. The only issue is that when we have something like PEMDAS, we normally just look at it and we say, okay, it's this, 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 and this, right? It goes in a placement. But when we get to what we're doing now, which is Postfix, it's going to look like this. It's going to look like, how about I erase this, right? And I go like this. I go addition, subtraction, that, and then parentheses and exponents. This is the heresy right here. It's 1, 2, 3, 4. This is how it goes. 4 is less than 3. 3 is less than 2. 2 is less than 1. Whatever happens, just remember this is parentheses, exponents, multiplication, division. Think of them together. Addition, subtraction. Think of them together. All right. And when we put things into the stack, it must follow that same exact order. Now, we're going to go ahead and pop. We're going to go ahead and pop. We're going to go ahead and pop the multiplication now into the stack, since I explained that to you. We all understand that. Multiplication is higher than addition and subtraction. So we're good. That means we could continue. Now, when we get to parentheses, it's a little bit different. Parentheses is a first. So when we open up a parentheses, meaning that we put it into the stack, it's an operator, but it has the highest of the heresies. So that means everything within inside of that operator has to be done first before we could return back to this colorful place right here. So we'll just go ahead and do that. So now we'll look at 3, since we put the operator in there already. So that's there. That's a parentheses. Now let's look at the 3. That goes into the field. It's an operand. Now multiplication is fine. That's cool because we're inside of the parentheses, right? So now we look at 4. What happens to operands? They go in the field. Now we have a dilemma. Once we get to subtraction, we can't have multiplication underneath subtraction. So what has to happen automatically, since it's a lesser tier, if you look up here, we have to pop this. We have to pop multiplication so that we can put addition in. So let's pop that. Let's pop this. I'm gonna do it in the green. We're gonna pop that multiplication. We're gonna put it into the field for the first time. All right. Now we could put the subtraction in there. So let's put the subtraction. Boom. All right, and that's the subtraction from right here. Boom. All right, I'm gonna put a dot. Then I'm gonna put a dot there. That's just for keeping track of it. When you actually do this a few times, it's a much easier process than me just going through really slow like this. But now we look at the next operator or the operand, because there's nothing else in our stack over here. If you see our stack, we have nothing else, nothing else that we're doing over there. Excuse me. So let's move on to number 2. Sorry if this is a little slow. We put 2 in the field. We look at our next operator, which is a caret. Caret's cool. It could go on top of the subtraction, which is an exponent. We call it the caret. Now we look at the next operand, which is 3. We say, all right, 3, you're cool. You could just go right in there. Now we close the bracket. This is another important step. So I'm gonna put 2 dots. So close the bracket. Little dot there. Well, so now we close the bracket, right? When I close it, I like to indicate that I closed it. So I'm gonna erase this. I'm gonna draw this back for our stack, and I'm gonna draw some colorful lines around it, because we still have to pop these. So I'm gonna pop them one by one. First, I'm gonna get rid of these brackets, since I already have a new bracket. Now I'm gonna pop my caret. Pop the caret. Now I'm gonna pop the subtraction. Pop the subtraction. Everything is brainless at that point, because we did all the necessary work, as you guys saw. We exhausted it at that point, right? So now what I'm going to do is I'm going to erase some of this. I'm going to draw a little bit higher into the sky here. I'm going to kind of cut that off. But now this is done. So if we highlight what we need to work with is right down here. We can't forget about these guys down here, right? But we'll have to build on top of what we already had. So I'm gonna just highlight this again. Say like this is done, right? So now we highlight this and we go, okay, we got to do that, right? So now we look at the net spot and we say, okay, that's a plus sign, and a plus cannot go over on multiplication. So that one is tricky because as soon as you close the parentheses, you have to understand that that's closed, and we go back to our previous place. So a plus cannot go over the multiplication. Now we have to pop that. We pop the multiplication, but this is the even trickier part. Since the plus and the subtraction are on the same level, one of them needs to be popped. And the one that gets popped is the one that's on the stack. Why? This is how it's done to do the infix to postfix. It has to get popped. So we pop it into the stack and we remove it. So now we're completely done. And now we start again with a plus. They cannot be of the same level. So if this was a plus sign, even if it was a division and a multiplication sign, they cannot be on the same level. Division and multiplication cannot be on top of each other. Addition and subtraction cannot be on top of each other at the same time. They have to be on separate levels. So I beg you guys to try doing this again, just to make sure that you got that understanding. But hopefully I explained it as best I could. Once we understand that, it's smooth sailing. We're home free, but let's go through the rest of it just cool as we can. So we have 3. That's an operand. We put it into the stack. We have multiplication. That's an operator. We put into the stack. Remember, it could go right on top of the plus. It's just like we had down here. It was subtraction, but it's just like that. Now, we look at the bracket. All right, that's parentheses. Let me just do it real small. We got a small little parentheses right there. Then we'll look at the 2. Right? We'll put the 2 straight in as an operand. Then we have a plus. Put the little plus up here. Boom. It's a little plus. It's a little plus. Put the plus up there. Remember, this is a parentheses. And then we have a 1. We put the 1 out there. And then what we're going to do is we're going to look at the last parentheses. We're going to close it up. Boom. That means we just close the parentheses. So I'm going to do a little bit of coloring work. I like colors. Colors just keep everything organized. I'm going to pop my only plus inside there. Because remember, we're in the brackets. Pop the plus. Go back to my colors. I'm going to close that off. And now we look at the highlighted part. We go, okay, so what's next? We just got to pop those last things, which is a multiplication. And lastly, give me a sec. And lastly, we're going to have a plus sign. And that's our answer right there. Sorry. That's our answer right there. So I'm going to go ahead and let you guys look at this really fast. If you guys need a full screenshot. I know I went kind of crazy with the colors. My fault, everybody. But that's our answer right there. And the power of, you know, the video is that you could go back, you could watch it again, and then see what I did. And like I said, you could have 2 times speed. I'm coming up on 30 minutes, so let me just do this a little bit quick. I'm going to pop it into the calculator really fast and then just get busy. So 7, 3, 3, 4, 1, 2, 3, caret minus multiplication minus 3, 2, 1 plus star plus. Okay, so I'm going to jump back over to the screen, y'all. Give me 1 sec to get this right. So, this is a math blog. It has an Infix Postfix converter. So we just popped in the same answer. I just made sure that I was copied correctly. I'm looking at it right now on my iPad. It's 7, 3, 3, 4 star multiplication 2, 3 caret subtract star multiplication subtract 3, 2, 1 plus multiplication plus. And that is the same exact answer as the Infix calculation. So if we look right here, that converted it. I already had it punched in, but that converted 7 minus 3 star 3 star 4 minus 2 caret 3 plus 3 star 2 plus 1. And it converts it right away. So I beg you guys, just try doing it again. And I guarantee you, if you just watch the video like even a few times, and like I said, just speed it up. If this video is like 30 minutes altogether, it's 15 minutes if you times to it. You don't have to go through everything, just the parts that you miss. We're just gonna go over through the rest of the information. So there's a few more questions. All right, check this out. So there's this question about code stack / q based on method. I guess that was supposed to say base. Oh, write a stack code stack / q based method that determines whether or not an array of character contains a palindrome. A palindrome is I'll look it up for you guys. I don't want to even get you mistaken what a palindrome is. A palindrome is a word, phrase, or sequence that reads the same backward as forward. Example, madam or nurses run. Like race car. If you spell race car backwards, it's race car. Nurses run is the same thing backwards. Madam is the same thing backwards. So I put review and come back because I have to look over the notes I have, make sure that this code actually works, and then we'll review that. This shouldn't take no more than 15 to 20 minutes. I'll most likely do that too before I get to the green, which is called the implementation of stack. Maybe I'll do them together, who knows. Let's move on to another question. So on fall 2018 final B, it says using an array implementation, would you ever need to resize the stats to solve this type of problem? Why or why not? So let's look at the problem, which is this one right here, not that one. It's given that you have a integer infix, and the question is asking you the following. It says, would you ever need to resize the stats to solve this type of problem? And what I have, maybe I'm wrong, but please tell me if I'm wrong or right. It's around the 33-minute mark, 34-minute mark. Using an array implementation, we would not need to resize the stats to solve the type of problem in part A. Since we already know the size of the expression, which is, if we looked at it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19, if it was 19 unique characters, since we already know the size of the expression, the stack size will be defined based on what is given. So 19. I don't know if you guys remember the code where we had I'm not too sure if I could pull it up really fast. When we had the code, um, I'm trying to remember where I put the code. I had the code somewhere, but I think it might be this. Give me a second. I have some notes here. But what I was trying to say is that since we know that the given size is 19, all we have to do is indicate that in the ADT. So we're given an ADT, and right here where it says private in, and then we have a size and then A, we could actually put the size inside of here where it says public in stack in size. We could indicate the size once we have the ADT implemented. So there wouldn't be at that point it would allow for calculations of the expression less than or equal to the size given of the expression. So if I put in 18 for, if I put in 19 for the actual size, pardon me, if I put in 19 for the size, I could work with things at 19 or less than 19. So everything would be less than 19 if I'm solving the actual expression. So there wouldn't be no need to resize it in my mind. That's the way that I thought of this question right here. Using an array implementation, would you ever need to resize the stats to solve this type of problem? Why or why not? That's my thinking behind it. You could tell me if I'm wrong. The time was around 34 seconds in the video. Just let me know what you guys come up with. It's the same thing for the summer test B, summer 2019 test B. It's that same question. We have another palindrome. We had a palindrome up here. We had a palindrome up here. Like I said, I'll come back to those. Now, given 7 minus 2, given this string of, this Infix algorithm, what property of stack ADT makes it well suited to solving the above problem? So this is why I kind of put everything together, because that fast we're able to get through most of the questions there, and that's how easy it should be for us to solve the questions on the exam, at least how it's supposed to be. So that's kind of why I kind of sped through it, and I kind of focused on the parts that could really trip you up. So that's why I'm coming back to the palindrome, and that's why I'm asking you guys to kind of tell me if I'm wrong, if I got the resize part wrong. But this, I'm fairly certain that I kind of got it right, but the professor's probably going to tell me no. A lot of the questions that we're going to answer now, the professor's going to probably tell us no, and then give us the way that he wants to answer it. But we have to present something to him. So what property of the stack ADT makes it well suited to solving the above problem of right here? Oh, stack ADT makes it well suited to solving the above problem because the stack ADT follows last in, first out, LIFO order. Last in, first out is a method that the last item put into the stack is the first item to, or the first to come out. So I don't know if you guys remember when we were doing the stack, when we put multiplication on top, if there's a subtraction that comes on top, we have to pop it first before we have the subtraction on top. So just in that order, rather than if, remember where we had that bottom part of the section when we were done with the parentheses, if we just had things coming out at the bottom, it'd be much different. So that's why I went on to explain. This is well suited for the expression due to the maintained order kept for postfix evaluation. Operations are performed after a given string of numbers. If we had used QADT, which follows FIFO, first in, first out, the operations would then be performed out of order for the postfix algorithm. I think I said it, verbalized it as best as I can, when I sat there and I thought about it for like 30 minutes, and I was just like, okay, how would I answer this best so I don't trip anybody up? But I think that's the best solution that I have for that question. That was around maybe I would say 37-minute mark, 38-minute mark, if you guys want to come back to those questions. So you'll have 39 or 33 minutes and 36, 37 minutes to check back out on the actual YouTube video. But that's about it. If you guys have any questions, let me know. But we handle all the yellow questions, so that's it for now. I'm gonna show you what we have to come back to, which is this one. I'm gonna put it in red. This one, I'm gonna put it in red. This one, put it in red, and yeah, I think that's about it. I think we did everything that we needed to. So there's only a few questions. There's exam number 12, exam number 7, and exam number 4. With that being said, I think that's about it. I'm going to save these questions for later. I'm going to just chill, get some rest, come back to it tomorrow. Well, a little bit later. Feel free to ask me questions. Feel free to drop anything, whatever you guys need. Just let me know. This is it for the video. Thank you guys for hanging out with me. I'll holler at you guys, and good luck with doing the Postfix evaluation. Just be sure to do at least 1 or 2 examples. All the information is there. Got you. Peace.